So the question here is the sequential price competition game. So one company, there are two companies. One is making an offer first, and two is making an offer second, and the applicant will choose whoever offers more, and the applicant's productivity is $20. So both companies wants to maximize profit. So if you want to draw the whole tree, then company one can propose any wage 0, 1, 2. So all of them. So I can draw like this until say infinity, and then two can make all the offers as well. So in this case, there are too many things to consider. So let's make it simpler by drawing only a few branches and hopefully covers all the possible cases. So here I'm going to think 18, 19, and 20. You can draw one more if you want, 17, but the tree is too large, so I'll only draw three here. So the reasoning, one intuition is if you offer anything larger than 20, I'm making a loss. So I prefer not to hire this applicant if I'm making a loss. So of course I will not offer anything larger than 20. So I will not offer anything less than 18 is not very intuitive. So you should actually try 17 and see. But if it's less than 18, basically the other company can offer one more dollar, and that other company will for sure get the applicant and make a large profit actually. So that'll be the reason why those numbers will be, usually they will not be stable. So so that's why we're trying only 18, 19, and 20. So here 18, 19, and 20 as well. 18, 19, and 20, and 20 is 18, 19, and 20. So if both of them offer 18, both of them will get the applicant with probably half. And the applicant can make $20, and I'm paying her $18, so I'm making $2 profit, but I get this applicant with probably half. So half the time I'll get $2, half the time I'll not get the applicant. So in expectation I'll get one. So these two companies are symmetric, so it's 1-1. In this case, if the first company is offering 18 and the second company is offering 19, then the applicant will go to the second company, and the applicant will make $1, well, make $20 for the second company, and the wage is 19, so the profit is 1, and the first company gets nothing. So similar here, except for the applicant also goes to the second company, and she's making $20, and the company is paying her $20 as well. So the company makes $0, and of course the other company makes $0 as well. So if you repeat the same process, here the first company will get that applicant for sure. So the first company is making $1. If both of them offer 19, both of them will make $1 profit with probably a half. So it's half half. And the last case is 0-0 for the same reason. And here, if the first company is offering 20, then first company will get the applicant for sure and make $0. So in all cases, it's 0. So the problem here is if you look at the first subgame, this is the second company's choice. So I'm comparing this number, and this number. I'm choosing the largest one. So the trick here is both of them are the largest one. So I need to separately consider them as two different cases. So I'm not going to highlight both of them. I'm going to highlight the first one, and then I'll assume the second player is always choosing this for some reason. And then I'll solve the game, and then I'll consider the other case. And here, the second company is comparing these three numbers, so I want one half for sure. And here, the second company is indifferent, so I don't care. So I can choose all of them. And then you solve the problem for the first company. So the first company is taking the second company's reaction as given, And we made the assumption that the second company will make this choice in this first case. So that's why if I choose 18, I'll get 1. If I choose 19, I'll get a half because I know the second company will react this way. If I choose 20, I'll get 0 anyways. So I'm comparing these three numbers. 18 is the largest one. So, so the solution here, one of the solutions here is both companies would offer 18. Again, that would be just the first case. So the second case is we disregard the assumption that facing with the same payout or the same profit, the second company will choose 18. Instead, we are considering the case in which the second company will choose 19 here. So let me erase these and draw them back. Sorry. Okay, so the second company again is comparing these and picking 19 in this case, and also picking 19 here and picking everything there. So now the first company, let me use another color. If the first company chooses 18, following the optimal path of the second company, I'll get 0 here. And if I follow this path, if I choose 19, I'll still get a half. If I pick 20, I'll still get 0. So now, comparing these three numbers, 19 is the best one. So I'm going to pick 19. So that's why another solution in another case will be 19 and 19. So note that the important thing is that the solution concept here is basically just a solution of the sequential game, and in game theory it's called subgame perfect equilibrium. It's not Nash equilibrium. So in the Nash equilibrium, we should convert this into a payoff table and solve for best responses that way. So here again, the solution is not Nash equilibrium. That's why we don't have one of the solution being 2020, which is a Nash equilibrium, but it's not a subgame perfect equilibrium.